Hello, this is Mr. Mello for section 11-6, Radical Expressions. So I know we talked about this a little bit with starting chapter 11, but remember radical expression are things like this, where we don't know the square root of them, but we're going to try and simplify them as much as we can. So this is one of the big reasons that we did those fast math sheets a little differently, was getting ready for radicals. And there's really no wrong way to do this. There's a slow way and there's a fast way. And the fast way should be knowing those square roots that we already do know, and then breaking them up like that. So like breaking up 18 into 6 and 3, probably not a good idea because we don't know the square root of 6, we don't know the square root of 3, but breaking up into 9 and 2, better idea because we do know the square root of 9 is 3. So remember those square roots that we do know, the 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are the numbers that we're really looking for to break down. Okay, so like I just said, so it's no perfect squares other than factors of 1. It has no fractions, no square roots can be in the denominator. If we ever do get something that says like square root of a square, we have to remember to put it in absolute value bars because it could be positive or negative. So we just put it in absolute value bars, but it's only if we get something squared. So for something like this, we have square root of 2 over 50, which 2 over 50 we can simplify over 1 over 25, and then we know the square root of 1 is 1, and the square root of 25 is 5. If I have something like this, 8 squared plus 15 squared, well, that ends up being 64 plus 225, which ends up being 289 when I add those together, and the square root of 289 is 17. C is one of probably the most harder ones. You only have a few of these, so it's x squared minus 6x plus 9, which if we unfoil that, so if we factor that, end up getting x minus 3 squared, which, like I said, if we get something that's squared under a square root sign, we have to put in absolute value bars. Most of the time we'll get problems like this. So square root of 256 over 4, so we can simplify that to 256 divided by 4 is 64, so square root of 64 then would be 8. Or something like this one where I have square root of 40 plus 9. Well, square root of 40 plus 9 is square root of 49. And square root of 49 is 7. Something like this. So 5 squared is 25. And 12 squared is 144. So if I add those together, I get 169. And the square root of 169 is 13. This is a little more what we did that one day. So breaking up the square root of 24. So again, there's a couple ways to do it, but if we try to use those numbers that are perfect squares, it makes it a lot simpler. So breaking it up, instead of doing like 12 times 2, let's do 24 or 4 times 6. Okay, and I do know the square root of 4 is 2, but I don't know the square root of 6, so I'm just going to literally leave it as 2 square root of 6. And the way I'd say it is 2 root 6. If I have something like this with with variables, it's kind of the same thing where I can only leave the exponents can only leave that square root box in pairs. Kind of going back to this. So square root of 4 means 2 times 2. So x squared means x times x. So I do have an x squared in there, and I do have 2 y squareds in there, which is why my answer is going to be y squared, because I'm going to have 2 sets of y's, and 1x with an x left over. So remember, variables can only leave in pairs, because really that's what numbers are. They're leaving in pairs. They're leaving that radical house in squares. So instead of it saying square root of 4, well, it's leaving as 2 and 2. Kind of the same thing with there. Instead of saying x to the third, well, it's really x squared and 1x is how it's leaving the house. Same thing here, 128. Again, if you can't think of one of those square root numbers that goes into 128, I wouldn't think about it for a long time. Break it up however you can. In this case, I would go with 2 and 64, which I end up knowing the square root of 64 is 8. Can't break down 2 anymore, so it's going to be 8 root 2. Here's another one. So again, remember they can only leave in pairs. So I can have a pair of x's leave and a pair of y's leave, which is why my answer is xy times radical x. Here's one with both numbers and variables there. So I have 48, which I'm going to split up as 16 and 3. Again, if you split it up differently, like 12 and 4, that's fine. You'll still get the same answer. It'll just take you a little bit longer to get there. So 48 gets broken up into 16 and 3. And I know the square root of 16 is 4. And I have a pair of a's that can leave. So that's why there's a 4a on the outside. And the 3b get left in the middle then. Fractions change nothing. You're literally going to do it the same way. Here I don't know the square root of 5, but I do know the square root of 4, and that's 2. So I'm going to leave it as square root of 5 over 2. Same thing here. This one I can actually end up simplifying both of them. So square root of y to the 6. Remember, they can leave in pairs. So I have 3 pairs of 6's of y's there. So y to the 3rd. And square root of 4 is still 2. So just breaking it apart if it's fractions, not any more difficult than that, just looks a lot more difficult. And then we will get into some problems, and it takes a long time to explain it over video. It might be a little confusing, but how we're going to be using Pythagorean theorem to kind of solve for when we're talking about that big diagonal. So remember, a squared plus b squared equals c squared.